This is the Learning Outcome 2 section, and this is the majority of the notes that you would need for your prelim and end of topic test on Friday. So in previous lessons we've gone through things such as the difference between server-side scripting languages and client-side scripting languages. We've looked at macros and we've looked at JavaScript. And so moving on that, we have to look at the difference between procedural, declarative and event-driven languages. Now you should have completed this in the grid that was provided. So this is just a sort of a recap, just so you can check that you got all the information that you need. But in procedural languages is an example of QBasic. But in a procedural language, the user sets out a list of instructions in the correct sequence. So there are no events in procedural languages, so there's no button underscore click functions. There are subroutines and there are functions, but there aren't any that wait on a specific event. When you run the program, it runs immediately and then stops. So it's got a definite start and end point. And here's some features that you might find in procedural language. So you've got different variable types like strings, booleans, integers, singles. It's not to say that event-driven languages don't have different variable types, they do, but declarative languages don't have different variable types, so it's a feature to look out for if you're trying to identify which of the three languages that you are looking at in the exam. Other features of procedural language is your mathematical and logical operators. You've got sequence, iteration and selection, so that is the fact that it runs code in a logical order. Iteration is your loops, your fixed and conditional loops, and selection is your if or case statements. Data flow using parameters, so you can pass local variables between subroutines, and to do that you need subroutines. So a feature of a procedural language is subroutines or procedures or functions. Examples of procedural languages would be QBasic, Pascal, Comal. Things where you don't have a graphical user interface designer. In declarative languages, and we've got a few of the animations up already. In declarative languages, it's totally different. So you don't say how to solve the problem, you say what to do. Okay, so in this example on the left, you've got facts like John is a thief. So the text in black would be your predicate. And we'll look at this in the artificial intelligence section, but this is a predicate, and John inside the brackets is your parameter. Okay, so reading that out, it would be John is a thief. And line 6, Mary likes food. Line 7, Mary likes wine. Line 8, John likes X. X is a variable, so you can have variables, but they have no specific type. This is an if statement, so the colon and the minus sign is if inside prologue, or certain types of prologue. So John likes X if X likes wine. And just by sort of glances through that, the facts, the three facts above, and trying to work out what's going on, we can determine that John likes Mary because Mary likes wine. Okay. So it's a rule-based language. Now here's some features. So you've got facts like thief John likes Mary food. You've got rules like likes John X if likes X wine. You've got recursion, which you can't see in this example, but recursion is where, well, I used the example, it's the image of the snake eating its own tail. So in a section of code, you can have a function or a subroutine that you've created call itself and pass a new value back, and that will create a new instance of that subroutine and continually work its way through calling itself, passing new values in until it hits a certain point. You have to code that very carefully, otherwise you end up with a never-ending loop. And lastly, the whole of a Prolog source code file is called a knowledge base because it's a combination of facts and rules. Finally, you've got event-driven languages, and this is the one you've been using in class. So Visual Basic or visualbasic.net is an excellent example of event-driven languages. By the way, an example of a declarative language would be Prolog. Something where you can create a knowledge base. Event-driven languages wait until a specific action occurs. So in the example on the screenshot, we're creating a very basic calculator. So each of those 12 buttons would set off a specific event when you clicked on it. And when you clicked on one, for example, you would want to run some code which would put 1 into the text box at the top of the form. Now if you just run the program and go away for a cup of tea and leave it, that program remains in memory waiting. So it's quite inefficient if you think about it, because if you are running a program which has got to process bills, you would probably use a procedural language because it's something that requires very little human interaction and can run probably overnight. So a definite start and end point, it would start at midnight, it would finish at 4 AM, for example. With event-driven languages, it's designed to have user input. So if there's no user input occurring, there's no point in having a graphical user interface with a button on it, because there'll be no one around between 12 and 4 AM to press that button. So event-driven languages remain in memory and wait for an event to occur, specific events to occur. And so they've got no definite start or end point. There are features of event-driven languages which make it stand out from procedural languages, and that is obviously it's quick to design its graphical user interface. You just drag icons from the toolbar and you set the properties in the properties box. And as I said, the feature of an event-driven language is that it's always running and waiting for something to happen. Now, it doesn't matter what type of language you use, whether it's event-driven or procedural. Declarative is a little bit different here, I suppose, but you can access module libraries. Now these are parts of a software library which can be used by any program when required. So you might have a collection of conversion functions, like from Celsius to Fahrenheit, from yards to meters, from miles to kilometers, all these kind of sort of calculations which you can now do in Google. If you put all that into a Visual Basic module, you could access that in any of your programs, and you wouldn't have to know the calculations or the mathematical formulas to work out the answer. So it could be quite handy. Saves up some time. So here's just some advantages of module libraries, and this is how a module library saves you time. Firstly, it's pre-written. Someone else has gone to the trouble of writing the code to do those conversions, so you don't have to do it. Secondly, it's pre-tested, so someone has made sure that if they follow the software development process, they've designed it properly, they've gone through the sort of creation of it, they've tested it, and they've worked out if there's any flaws and hopefully corrected them. So you can say, if you buy a module library, for example, you'd be pretty confident that that section of code has been pre-tested, and that again will save you some time in your entire software development process. And finally, it's been pre-documented, so you can go back through the module libraries, and every line of code should have a comment associated with it, or there'll be a sort of description at the top of the subroutine telling you exactly what it does. And again, this will save you time because you don't have to go through and document the code yourself. Also, it'll save time in the maintenance stage because you won't have to go and sort of decode all of the pre-written module. This speeds up the software development process. Now there's a few more things to go. We've got the difference between compilers and interpreters, and because we did this in systems, you should know that an interpreter converts one line of code at a time into something the computer understands, executes it, and continues if there are no errors. Whereas a compiler takes all of the source code, compiles it at once, takes note of any errors, and if there are no major errors, will output some object code which can be run. Now there are disadvantages to each. Okay, the main one being that with the compiler, that you cannot debug as easily, because it displays all the errors at the end. There might be 100 errors, and which one do you start with? It's very difficult to make that decision. It could also be that one error earlier on will cause 50 errors later in the program, so it's not that helpful. So it's better to use an interpreter when you're building the program, and a compiler when you've tested it and you're happy that it's ready to go. So a compiler translates source code to object code. Once it's compiled, it can be run. But here's the key thing: you can take your object code, your executable, or in this sort of picture instance the flash SWF file, and you can run it on any machine which has the same computer architecture, same processor, without the source code and without the compiler program. And this means that it will be slightly more memory efficient for the end user than using an interpreter. Like I say, with interpreters you run programs one instruction at a time, but no object code is produced because the interpreter just runs the code directly. So this means you need the source code at all times and the interpreter application at all times. Whenever you want to run that program, you have to load up in the interpreter, feed it the source code, and then hit run. Now this obviously takes up much more memory than the compiler. So here's a comparison table. Compiler's faster to run the program because it's been converted into a language that the computer understands. The interpreter is slower because it has to translate what you've written in sub-English into machine code every time it's run. With memory usage, the compiler is again much more efficient because it doesn't need the interpreter program or the source code to be in memory. However, with debugging, the interpreter is better because the user can trace the syntax errors more quickly because it stops at the first error. With debuggers, it will give you a long list of errors at the very end of the compilation process. Now, speaking about the compilation process, you're kind of quite used to it being a black box where you give it source code and it outputs object code and maybe an error list. But there are specific stages involved in the compilation process, and at higher you've got to know about these. So here they are, 3 stages. These are keywords that could come up in the exam or the prelim: lexical analysis, syntax analysis, and code generation. And the source code passes through each of these 3 stages before object code is generated. So in the first instance, lexical analysis, it goes through the source code and it converts each keyword. So for example, MSG box would be a keyword, if would be a keyword, and it compares it to its internal dictionary, and it turns any recognized keyword into a token. That's a lexical analysis. It doesn't do anything with the parameters, it doesn't do anything with text values or integer values. Anything that's a keyword, something that would be highlighted in blue in Visual Basic, turns it into a token. At the second stage, it passes the source code through again, and it checks any of the statements which have been changed to a token. They will have grammar rules, a bit like English, with verbs and nouns and adjectives. There are specific sentence structures. In Visual Basic, for example, you can have 3 ways of using a message box. You could have an MSG box with 1 parameter, with 2 parameters, so the text to be displayed and the type of button you want to use, or 3 parameters, the text, the buttons, and the title that you want displayed at the top of the message box. And so what syntax analysis is doing is it's just saying for any token which matches a message box, check that it's got either 1, 2, or 3 parameters that are of the correct type. If it sees one that's got 4 parameters, it'll stop at that point and say there's a syntax error here. Or if it's using a different data type in any one of the parameters, then it'll know that that's not what's expected, so it'll stop with a syntax error. It'll go through the whole source code, making sure that there are no keywords which have been misspelled and therefore not changed into tokens, and also no extra or missing parameters or incorrectly typed parameters, as in data types, not entered. And the syntax analysis is usually done by a parser, because that's another keyword. A parser is something which performs syntax analysis by looking at the structure of each individual line of code. So once you've got through those 2 stages, you can be pretty confident that the code is going to function correctly when run. So the code generation process takes place, and this is when it turns into the object code. So everything is passed through the code generation stage and turned from what was your sub-English source code, which is now sort of a combination of tokens and values, and it turns all that into zeros and ones, and that's saved as object code. Now, when you run the object code, you might still crash because you've got errors such as memory leaks, or it might clash with another program which is trying to access the same location. It's not definite that if you go through those 3 stages that your code is going to work without issues, which is why you still need the testing stage. But this will cut down the number of errors that you